Now, students, today's topic is how to calculate the average power in an AC circuit. As you know that for AC, the equations of their potential and the currents are given as follows. For potential, we have E equals to E naught sine omega t, where you know that E naught is the peak value, omega is the frequency, and t is a time instant. And I equals to I naught sine omega t plus phi, where I naught is the peak value of the current and phi is the phase difference between the EMF and the current. Now to calculate the average power, we have to choose the time. For average power, the time interval is from 0 to t, where capital T is called as a total time period. And this can also be represented by this equation that T equals to 2 pi by omega. This is a very important equation, or we can say that you can also write it like this way: omega t equals to 2 pi. Is it clear? Now, to calculate the average power, first of all, we have to take a simple formula. You just think for the simple calculations. You know that the power is given by the rate of doing work. Now, the work done is also given by, suppose we want to do the work done, this can also be given as P times of dt, integrating it within the limits of 0 to t. Is that clear? Now here the power, as you know that for a simple calculation, the power is nothing but the power is a product of E and I, a simply E and I, if this is a DC circuit. But here we have the AC circuit, therefore we have to replace this E and I with the equations. Now, work done 0 to t, E, I and dt. Now here replace the values. 0 to t, it becomes E naught sine omega t for your E, and I naught sine of omega t plus phi for current. And this is your equation. And you just put a dt mark over here. Is it clear? 0 to t, E naught sine omega t, I naught sine omega t plus phi into dt. Now, we take E naught and I naught because these are the peak values which are to be taken as constant. We take them out from the integration sign and multiply the equation by 2 up and down. That means in numerator you multiply by 2 and in denominator you multiply by 2, so that there is no change in the equation. So by doing that thing, the next equation is work done equals to E naught I naught divided by 2, integration of 0 to t, 2, we are left with sine omega t, sine of omega t plus phi, and then dt. This dt is called as an integration factor. Is that clear? Now, you know the formula of sine A, sine B, or you can say sine C, sine D. The formula is cos of A minus B minus cos of A plus B. Is it clear? Here it is 2. If we take omega t as A, so it becomes sine A, and omega t plus phi as B, it becomes sine B. So we get cos of A minus B minus cos of A plus B. Is it clear? Now it becomes E naught upon I naught, and in the meantime we convert the 2. We can rewrite the 2 as the product of root 2 and root 2. Now here integration by using the formula, we get the value as cos of phi, because on subtracting omega t, if we take it as a, omega t minus phi, omega t and omega t cancel out, we're left with minus phi, and you know that cos of minus phi is plus cos phi. Similarly, we have the minus sign. Now cos of a plus b, so we get, on adding these two, we get 2 times of omega t plus phi, because here a and this is your b. Is that clear? We get 2 omega t plus phi. We take them into brackets and put the dt sign over here like this. Is that clear? Now, here this I naught upon root 2 is called as a virtual value or the RMS value of the EMF. Similarly, I naught upon root 2 is called the virtual value or the RMS value of the current. So replacing them, we can write as ERMS, IRMS. Now here integrating, as cos phi is a constant, we have to integrate with respect to t. So we get t cos phi, and on integrating the cos omega t plus phi, here we get the answer as sine of 2 omega t plus phi, and you know that while integrating we have to take the coefficient of t in the denominator, that is here it is 2 omega. Now closing the brackets, and we have the limits from 0 to capital T, which is a time period. Now replacing the values, here it is your ERMS, IRMS. On putting the value over here, it becomes t minus 0 cos phi minus, if we take the omega t as common, on putting the capital T, we get 2 omega t. Is that clear? What we get? We get 2 omega t. On putting the t over here, plus phi and minus times of sine of phi by putting the t as 0. Is that clear? Closing the brackets. Now, here we get ERMS, IRMS. We are left with only t, so we get t cos phi minus 1 upon omega. So here, in this factor, here 2 omega t, as I told you that omega into t becomes 2 pi. So on replacing this omega t by 2 pi, we get 4 pi. And you know that sine of 4 pi plus theta is sine theta. Sine of 4 pi plus theta is sine theta. So we are left with only sine phi and other minus sine phi. Is it clear? These two sine phi cancel out, and we are left with only, the equation remains here, work done as ERMS, IRMS, t times of cos phi. Now, simple power, average power is work done upon total time. Here, the time is from 0 to t, so we had only t time interval. So putting the value of W, ERMS, IRMS, t cos phi divided by t. On dividing by t, we get the average power as P average equals to ERMS, IRMS and cos phi. So this is the actual formula. Now one thing you should know here, cos phi equals to called as power factor. This is the only deciding factor. This is called as a power factor. This will decide the value of the average power while we are dealing with the AC circuits containing the different components, like containing the R only in the circuit where the resistance is only there, then the cos phi becomes 1. If inductor, then the cos phi becomes 0, and capacitor, it becomes 0, and for all the other cases. That only depends upon the value of the phi. So this is for all today. Thanks and have a very nice day.